8-minute video. Welcome. Alright, it's run. Okay. So if you want to show why is the not exist, can you find for me what is the left? What is B on the left? What is the left side of B? They go to left side is here, right? They go to positive infinity. And the right side, they go to negative infinity. So that means they're not equal already, right? They violate this one already. So that's why they does not exist. Yeah? They need to, the left and the right, they need to go to the same point. And if you evaluate at that point, they need to be exactly the same as well. Make sense? Yeah, question. The right one needs to be negative infinity. We gotta go down. We go down right here. Negative infinity. Alright, C. What is the limit when x go to C? When x go to C? Easy, right? That's right. If and only if the limit on the left equal to the limit on the right. That's it. That's it. You don't need to be equal to the limit at the point. Okay? You don't need this. This is for continuity. I don't know if you read my message. Did you read my message? Yeah. So this is the limit definition. Because we combine limit and continuity, so I was make a mistake. So the continuity, that's the one that you need. That you need the point. Okay. Continuity is when S is, the function is continuous. The function, hi Melissa, is continuous. Yeah, so that's continuity. Right, yeah. IE, you know IE, right? Or aka SNOS. The limit of fx equal to the limit of the whole thing. Because this here mean the limit is s, so then that's also mean the limit of the function when x equal to c will be equal to the function evaluate as c. Okay? So these two these two definition is the one for the unit 2. We review the limits and continuity. So again, we want to make correction. Last time, we make the definition of the limits. We have this condition, but no, the limits doesn't require the point, the actual point. Okay, so that's why when on the example I give you, I think example 2 or something. The picture, let me see. This picture. This is your example 2, right? And last time, example 2. So limits of function when x go to c, what is it equal to? Equal to 5. Okay. Even though the function at 5 is not at 5. Oh, the function at c is not at 5, right? It's actually some, maybe we can make it up, some number here, maybe like 7. But because the left side of the C, they go to 5. And the right side of the C, they go to 5. So the limit of x go to C equal to 5. So maybe you can correct that on your sample. I think this is sample 2 and part C or something. Yeah, fix that one. Okay, we good? So only continuity, only continuous, only continuous. Continuous, what is the definition of continuous? You can think continuous like you can draw the function without lifting up the pen. You can think that is. If you lift the pen, that means it's not continuous. Okay. What kind of discontinuity is this? Huh? No. Jump it like this. Jump it like this. Removable discontinuity. Is that what you learned too, right? We have 3 types, 4 types. We can go to continuity next time. The jump discontinuity, removable discontinuity, a whole, for example. Okay. Are we good? Can we erase it? It's okay. We're gonna keep it. Assemble. What assemble did we got to? 5, 4. Maybe the picture is choice. Let's erase it. No, the way they draw this look like that. Anyway.
But if it was open, would it be under?
It's no, yeah, right? Because the left side equal, the right side equal, but they're not equal to the point. That is the term discontinuity, right? Did you learn all 4 types of the discontinuity, right? Yeah. But at least it ring any bell, right? That is trigger something, right? Okay. Assemble 1, now assemble 2. Now this is the one that I said plug and check. What you gonna do? What you gonna do? You just need to plug in, and then that equal to. How about this? Oh, why were you guys? Oh, you not finished yet? Uh-oh. My bad. You have a recording though.
Yeah. So do you have to put a hopper tool? Yeah.
Huh? What you gonna do?
The hopper.
You can do loop it all, or you can do. You can. One of the method. What is that? You factor and simplify, right? How you factor this? X squared minus 9 is x plus 3, x minus 3 over x minus 3. Cancel this. You have x plus 3. So that's become 6. What is this? Oh, we only have 4 minutes. Alright. We're not gonna finish then.
Speed run.
No, we're not gonna finish. But you still have homework anyway. A lot. Alright.
Where?
How? Where? Oh, because calculus PC. It's here. I'm gonna give you. Okay. How do we do this? Let's just finish this one and then we're gonna give you homework. You have weekend. How are we gonna do this? One of the strategy I gave you. Not praying.
Expand.
Give up. You could. Easier thing to do. Do rationalize. Very good. You multiply everything by the conjugate. What is the conjugate of this? What is the conjugate of this one? What is its brother? Exactly the same, but just different sign. So copy exactly the same. Exactly the same. But now this is negative, now you put the positive. Whatever you do to the top, you need to do to the bottom. You cannot just do one side because that means you manipulate the value. It's violate the math. So now what does it become? So what does it become? A plus B, A minus B become? A minus B, A plus B become A square minus B square. So now that one become x plus 3 minus square of this is 3. On the bottom you still have this, but it's okay because it's still, you can still plug and check, right? Cancel this out. You have x. Only x on the top. Now I think you can plug it in. Right? Now I think you can plug it in. What is it equal to then? Oh, you can do more. You can do more. You see something we can do more? You can cancel. Cancel the x. And now you have 1 over x plus 3 plus square root of 3. Plug it in. Can you plug and check now? Yes? 0 plus 3 is 3. Oh, that's slow motion. You liked it. Square root of 3 plus square root of 3, you have what? Steven, you have what? You have 2 square root of 3, right?
You just combined it.
Huh?
You just combined it.
Oh, you plug in 0.
No, yeah.
You plug in 0, you have 1 over square root of 3 plus square root of 3. So 1 over 2 square root of 3, right? If you want to rationalize it, multiply everything by square root of 3, you have square root of 3 over 6. Again, limit continuity only take you 4% or 5% or 7%. So we're not gonna spend a lot of time on limit of continuity. What is the limit of function when x go to negative infinity? When x goes to let's say 2. Go to 4. And then the last part is where is the function continuous? Yeah, continuous. Right? Now let's do this one. All right. Yeah, let's write down. Okay. Ready? All right, let's go. Let's go. When x goes to negative infinity, how many pieces of function we have? 3, right? You know what does it look like? Oh, absolute value and then square root. What does the square root function look like? You know how to write them? X plus 3 is a linear, right? X plus 3 is linear. When x equal to 0, the whole function is become 3. So 0, 3. When x equal to 1, right? X less than 1. When x equal to 1, the function equal to, oh wait, square root of 3, my bad. Let's do it again. When x equal to the 0, the function becomes square root of 3. What is square root of 3? 1 point something? 1.86. 1.86 around this. Square root of 3. Okay? Is that correct? Or am I checking it? Yeah? She didn't trust me. I don't judge myself too, so check it. Check it. 1.73. Anyway, you got it. Square root of 3. Just draw square root of 3. Okay? When x equal to 1, oh, that's the easiest one. 1 plus 3 is 4. Square root of 4 is 2. So 1 and 2. Yeah? Now x equal to 1 is somewhere, y equal to 1 is right here. So they cut it right here. Now square root. We're checking more. When x equal to negative 1, let's see what happened. When x equal to negative 1, negative 1 plus 3 is 2. Square root of 2. Square root of 2 is 1.4. Hopefully it's correct. Square root of 2. Okay. So when is it 0? When it is 0? When this will be equal to 0. When x root of 3 equal to 0, right? You know what the absolute value function look like? If you forgot, you can look at here. I have absolute value function, the third one. They're going to be look like a V, right? Because they're always positive. So you need to see some V right here. So you need to see where they will be 0. So solve this. What do we have? X equal to negative 3, right? Solving this. So negative 3, 1, 2, 3. It's right here. So when x equal to negative 3, the point is like this. Oh, what does it look like? If you keep going to infinity, what do you think we're gonna have?
It's gonna go up.
Yeah.
Which problem are you on?
Oh, we're on the first one.
For 2.5?
Yes. Oh, no, this is the lesson.
Oh.
We're gonna go over homework tomorrow because I want to finish the 2A. This is still on 2A because we didn't finish the lesson 2A last time. That's why. Lesson 2A continue. Sorry, forgot to write down the title. Today is 8:24, right? 35? 25, okay. Yeah, so we're gonna do lesson 2A, limits. We'll continue on limits. So the function of this one gonna be like this. Okay, they should be like this for the rational. They should be like this. I mean square root. Square root should be like this, but because we have absolute value, so they're gonna be like the B. Okay. You have decimal anyway. You have decimal. You can check the function. But when you think about this, you can use the calculator using the numerical strategy. Plug it in some big number. What do you think we're gonna have? Let's say you're gonna plug it in negative 100. Because we want to see where they're going, where the function go when x goes to negative infinity, right? Negative infinity when the number is very, very big on the negative infinity. What do you think where they're going? To?
Positive.
Down?
Positive.
Positive what?
Infinity.
Positive infinity, right? You can plug it in any number, plug a check. Oh, that's different thing. But anyway, you can plug it in like negative in 100. You get some 97, square root 97, right? If you plug it in 1 million, you're gonna have like 999,000 square root of that, right? The number keep going very big. Do you agree? So that means this going to the where? Positive infinity. You don't need any magic to do this. When x go to 0, when x go to 2, which part is that? 1, 2, 3. The 2, right? So somewhere around here. You remember how to graph the rational function? I think you learned it in him, right? If you take Mr. Train, you learned it in him, right? Rational function. If you didn't take me, so I think you took Mr. Train, him, right? You still remember how to graph the rational function? Stephen, Brad, Emily, Isabel. Did you learn how to graph rational function? Okay. So rational function, they have horizontal asymptote, vertical asymptote. Did you review that on calculus?
Yeah.
Yeah. So how do you graph this? The bottom gonna tell you the bottom gonna tell you the vertical asymptote. What is the domain? What is the domain? What number gonna make math wrong? You can think like that. 2, right?
So
X equal to 2 is the vertical asymptote. What does the asymptote mean? The graph never pass, never cut, never cross. Okay. So you don't have anything fancy outside here. So that means the horizontal asymptote is still on the x-axis. Okay. So let's write down. Let's take a note. You feel free to take any note in your paper. Okay. You don't need to like copy exactly the same. Add on a note for yourself because you're the one gonna learn it. So x cannot be 2. So you can say this is a vertical asymptote. And you don't add in anything, you don't minus anything. So that's why the horizontal asymptote is still y equal to 0. Okay? So nothing adding. Take note for yourself. So y equal to 0 is horizontal asymptote. Okay? So literally you can just plug in a number then. You can plug in a number, you're gonna get the function gonna be something like this. Okay? Now, but if you look at this 2 right here, you can tell already where the function going when x goes to 2. When you look at this function right here, they D and E does not exist, right? Why it does not exist? Very.
Because one is positive infinity. And
That's it, right? The left side they go to positive infinity, but the right side they go down, right? They're not going to the same point. So it is D and E does not exist. Now when x go to 4, oh, that's one of the easiest one I think. Can someone answer it? Huh? Can someone answer it? Marissa, do you have any notes, anything? Do you have any notes? Yeah. Okay, that's good, that's good. So that I don't need to write, and it's good. Thank you. Yeah? X equal to 4, how we do it? Someone just say it? Irma?
See, plug it into the.
You plug it in. This is the one you're gonna plug and check. Because when you plug it in 4, I'm gonna find where is the left and where's the right. Are they going to be the same function? Are they going to be the same function? No, right? The left side of the 4 is the second one. But the right side of the 4 is the bottom one, right? So you have two different functions. So you need to see that if they go to the left and the right, they're going to be the same number, okay? So that's why the definition limit is here. Now let's check. We don't know. Now let's check. When x goes to the left, okay? The left means this part right here. Plug and check. 4 minus 2 is 2. Negative 2 over 2 is negative 1. So you plug it. Let me just write it down. So negative 2 over 4 minus 2. So you know what's going on. Negative 2 over 2. Negative 1. Okay? Now on the right. Let me write here. So you can see. So on the right, limit of x go to 4 plus on the right. You plug in 4, what do you have? 1/2, that's right. 4 over 8, 1/2. Is it the same? No. So what is your answer? Does not exist. D and E. Easy. Easy. Alright, where is the function continuous? Remember, I literally said erases. So continuous when this one's satisfied, okay? When the limits of x go to that point, actually equal to the actual point, okay? So that's continuous, okay? So where? In what interval are you going to be continuous? Continuous means you can draw the function without lifting your pen. Okay, you can think like this. There's no hole, there's no jump, there's no removable. Yeah, Jay?
Infinity to 4.
So we have negative infinity to 4.
4 to positive.
4, and then we have another 4 to positive infinity. Also, you mean the 4 is a discontinuity, right? Do you agree? Is 4 is the only point that you're going to be discontinued? 2 as well, right? 2. That's right there, the vertical asymptote. So we're gonna fix this one. Negative infinity to 2, and then 2 to 4, and then 4 to. That's it. Good. You found it. That's right. Very good. Well, you make my life very easy. I don't need to explain anything. You got it. Negative infinity to 2. That's continue. And then you have a vertical asymptote here, and then 2 to 4. This function is linear, so easy. Right. Question. Ask me any question.
Is it because
That's also this. Yes, that's also one of the clue. But let's see if you didn't do this. You just this question. Then you're gonna look at the function, right? But if you only have this, that actually show you where they discontinuity. Very good. Discontinuity happen when the limit does not exist, right? Because when the limit does not exist, this is gonna be wrong already, right? That's not gonna be happening already. Very good. Good observation. Any question? Okay, now last example, so that we done 2A. Look this door, we can do together easy, but we're gonna do as a homework, okay? This one I just go over some basic thing, very basic to review it. Actually, how about this one? Example 6. Alright, how we do this one? Looks scary. Intuitively, when you see some problem like this, what do you want to do first? Huh? What? Cry? Pray? Quit? Oh, we should add another, huh? K is crying. So intuitively, I mean, what I would do every time I see some limit, what I would do is I'm gonna plug it in first, right? I plug it in first to see what's going on. Is that going to be like indeterminate, like you can use a L'Hopital, or what's wrong? Then I can go from there to decide what method gonna work. So if you plug it in 2, you see what happened? This is gonna be 0, right? Oh, by the way, you know the limit of 1/0 equal to? Ooh, okay. Let's review that. Limit of 1/0 is what? No. How about 1/infinity? Okay. L'Hopital always happen applicable when you have 0/0, infinity/infinity. This is what they call indeterminate, right? This is what they call indeterminate. But this one is determinate. Yes, this one you can do it. 1/0. Okay, how about this? X go to 0, 1/x. Okay, to be formally, it's like this.
It's 1/1.
Huh?
We know
Ln.
it's 1/1.
Ln. It is infinity. 1 divided by 0 is infinity. Very good. You didn't learn that?
We never did this. I thought it was 0.
Is that 0?
I don't remember.
How about this? Then write down then. Write down.
Oh my god.
Recall. Maybe you can write recap, recall, whatever, to remind yourself. Exactly. 1/infinity is 0. Always. Yeah. When you divide by 1 to the number on the bottom getting very big, what did you get to? 0. That's right. That's why when x goes to infinity, 1/infinity is 0. Okay? And when you're getting very small, the bottom getting very small. Like, okay, you think like this. 1/1 is 1. 1/0.1 is 10. Good. 1/0.0001. 1000. Right? It's getting... No. The bottom gets smaller. The answer gets bigger. That's why they go to infinity. Make sense? When you understand it, you can memorize more. Okay? Yeah? Yes? And when the bottom getting really big, they get to the 0. Think about that. That always makes sense. Okay? So when you see 1/0, that's infinity. What 1/infinity is 0. Okay? Only when you see 0/0, infinity/infinity, then you need to use the L'Hopital. Okay? Alright, how about this? My first thought going to be I'm gonna plug it in to see what's going on. Okay? I'm gonna plug it in. Maybe I'm doing on the sign. 2 minus 3. Oh, it's not 0. So it's good. 1/, oh, this one is 0, right? 0 squared is still 0. Now how about this? I plug it in 2. Oh, I do get some number out. 1/6. Can we do this? Actually, yeah. We don't need to do any tool. You don't need to use any like trick anything here. 2 minus 3 is -1. 1/0 is infinity. Infinity plus 1/6 is what? It's still infinity, right? -1/infinity is 0. Negative 0? Negative 0? Oh, that's a good one. Yeah? So now you can write your answer formally. You can write formally equal to limit of 1/0 plus 1/6, and then this one's equal to 0. Or actually, this one can be your answer too. So always plug it in first to see what's going on. From there, you can decide which method you're going to use. Okay? Very good. That's why I love teaching calculus basic. So you always need level, I don't need to explain over and over again. And the concept is interesting. Okay. Do you remember the definition of derivative?
The what?
Derivative. The derivative. You remember?
D over dx.
We know how it is. We just don't know.
Derivative of A equal to what? Carry.
F
F.
X is it X minus H?
It's a limit though.
Oh shoot. I don't know.
X equal to A. X minus A. F A minus F X minus S A. Remember this? For sure you learned this already.
Is it still 2A?
Huh?
Is it still 2A?
A?
Is it still 2A less than 2A?
Oh, it's still 2A, it's still 2A. It's still 2A. 2B is going to be Swiss theorem because you didn't learn Swiss theorem, right? So we're gonna separate that lesson by itself. 2A just limits. The homework I get you, that's basically a review. Because in order to do that, I think you need to look back to your AB calculus, or even you can Google it. That's fine, as long as you know how, you remember yourself how to do it. So that is your review for limits. We're gonna have some quiz. Remember, quiz on limits and continuity. Quiz. Thursday.
No, we got that.
Wait,
Thursday. Thursday is the quiz. Tomorrow lesson 2B. Huh? Why? Why not?
We have other quizzes this whole week. Every teacher is giving us quiz.
And then I ready.
So you say,
Monday.
so you're telling that you want to give up the class so that you can do the other classes? Oh. Who said that? Yeah, right. Very right. I just said that. Who said that?
You're still recording yourself.
It's internal use, okay? Don't post anywhere else. Delete this part, okay? Delete this part. Okay. So I know, I delete it myself. Okay. Short quiz, maybe. So it's going to be a short game. How about this? How about 17 problem?
Oh, okay.
No, 17 limits. 17 limits. Like this, easy. It's not going to take you that long, okay?
Okay, wait.
We have whole period. You have whole period. I'm gonna give you a whole period. You have like 1 hour
How about 9?
on Thursday. 9. It's not going to take. Yeah, not going to take you that long. Yeah.
It's Melissa's birthday.
Huh?
Which means you should give her less.
No, we gonna. So Thursday, come in. I can review with you a little bit. Then 45 minutes, the end of class, and we're gonna do the quiz. Just 17, one page, front and back, one page. Yeah? Who plays Sudoku?
Me.
Oh. Maybe we can do Sudoku on a quiz.
Yay.
That's fun. That's so fun. That's gonna be fun. Then I can give you the whole period then. Yeah? Oh, I love playing Sudoku, but long time ago.
So fun.
It's fun. It's fun. Is this one raise your hand? Okay. You're Sudoku. You're like, oh, okay, no question. Alright. So the direction for this is gonna be phi F and A, such that such
Wait, is that an ad?
such
Wait, mister, that's an ad?
F and A
Oh.
and like this. Try to do fast. If you don't know what is Sudoku, if you did and you don't know how to play it, Google it first. Thursday we're gonna play Sudoku, okay? We're gonna do limit and Sudoku. That's gonna be fun. No, it's a quiz. If you don't do it, you get a 0. Not extra credit. That's a quiz. People, that's a quiz. If you're ready, Alright, based on the formula, limit x go to a, function f minus function a over x minus a, right? X minus a. What is your a there? A is 2. What is the function f of x?
3 to power of x.
What is 3 to power 2? Is that the one?
Yes.
Is that the 3 to the power x? And then when x go to a is 2, right? So literally, this is exactly this. This is the fx. This is the f of x. So function f of x is, what is the function f of x? Can you see it? So here, look at this one. Limit x goes to a. Or they say x goes to 2. So that means a equal to 2. Are we good in here first? Okay, now keep going, okay? Now the bottom is good. We already did it. X minus a, x minus 2. A is 2. So that's correct. We done it. Now we need to check this one. Does it match with this? Otherwise we need to manipulate it to make it match. But look at this one. Function f of x. I see this one. So my thought going to be what? F of x equal to 3x. Is it correct? I'm gonna check, okay? I'm gonna check the second one. It should be f of a, right? My a is 2. So let's see f of a. F of a, my a is 2. That means f of 2. What is f of 2? If this is correct, then what is f of 2? You plug it in to the x, right? 3 squared is?
9.
Oh, actually it's correct. So we check it. Does it make sense? Want me to go over again? So I'm matching the term by term. What do I do? I compare and matching the term by term. X minus a, x minus 2. So I'm thinking a is 2. And then I'm gonna see f of x equal to 3x, 3 to the power x. I'm thinking this is the function f of x. Okay, but I want to check to make sure. To make sure 9 is actually f of a. A is 2. So f of a is f of 2. And if this is correct, then f of 2 equal to 3 to the power 2. That is 9. Oh, which is matching. So f of x is 3 to the power x. That's correct. Yeah, check. Good? Okay. And then a is 2. Just matching term by term. That's it. Do you want to also do like sweet theorem today? Sudoku maybe Tuesday, maybe tomorrow, and then Thursday test quiz. Let me check if you understand what's going on here. Let me see. One more. F. So let me see if you got this. You're just matching the term. Just matching the term. Okay?
No.
Hi is good.
Are
Yeah.
we still fighting F and A?
Yes, still under the same direction. Phi, yeah. So maybe this is A and this is B. Thank you for clarifying. So part P is still the same. Part B finding F and A. How about this? What time we done? Oh wow. Oh wow, never mind, only 6 minutes. I thought that we can do the lesson. So tomorrow we do lesson sweet theorem and then we play Sudoku. And then we go over the homework if we have time. Which I don't think we have. Then and then Thursday we're gonna do the quiz. Okay? Alright, what is A? A is pi over 4. What is the function you think that f of x is? We can check later, but what is intuitively, you look at this directly, immediately, what do you think? Tangent, okay? Now let's check. Now we're gonna check if this is correct, okay? We're gonna check. How do you check it? You're gonna check if fa is 1. Because that's the formula, f of a, right? You're gonna check if fa is 1. What is your a again? Okay, so that means you need to check f of pi over 4. Now, if this is correct, we're gonna check tangent of pi over 4, which is 1. So this is correct. So your tangent x is correct. That's your answer. A equal to pi over 4. F of x is tangent x. Sometimes multiple choice they can ask you this. So think about how to do that.
Wait, mister, what if they
Yeah.
don't, what if they don't match? What would be that?
If they don't match, then that means you need to manipulate something on the top to find what is the fs and what is the fa. To manipulate it. Yeah. Usually something like this, something look like complicated. That's the function. Because when you plug it in number, you're gonna get a beautiful number. So that's when you plug it in already. Yeah. What a good question. Yeah. Maybe we only have 4 minutes. We can go over one problem, one homework problem. Is there any homework problem you want me to go over? Yeah. Oh yeah, that's right. We can go over one homework problem for the last 4 minutes. You want to go over everything? 2.5. Okay, sure, yeah. One homework problem. Which one you want me to go over? 2.5. That's 2.5 has a lot of good question. Yeah, which one?
29. Go to 29.
29?
Yeah.
You know what? Jay asked me this one. I think this is good one. We're gonna watch it tomorrow. I think now I remember. Now remember this one. Sorry. Now 33, right? I want to ask you if you learned this already. Is that 34? I want to ask you if you know the definition of E. Do you know this? Did you learn this?
No. And?
That's the definition of E.
What?
That's the definition of all the number. So write it down. Write this one down. That's why I think it's very important.
Number over there.
34. N.
No, other.
N. So N go to 0. Do you remember on the list of the strategy? One of the strategy is we write the limit we love. Remember that one? That's the limit we love.
Is it?
Yeah.
So 1 plus 1 half? 1 over.
Oh wait. Okay.
So that's the only limit we love.
1. Okay, how about x? Okay, let's do the x so you know it. X. X go to negative. Go to infinity, not 0. My bad. Now this one go to 0, but this is 1 over x because 1 over infinity is 0 and to the power x. Yeah, right. Without that one down. That's the definition of E. Just write down. We're gonna talk about it tomorrow. I don't think we have time. Just 1 more minute. You can start backing up.